All right, moving on to the multiple comparison tests using the life expectancy example. Recall that we rejected the null hypothesis and we accepted the alternative hypothesis that at least two of the population means are unequal. But we have a problem because the sample sizes are unequal. So what that means that the number of countries from each continent are different. That means we cannot use our formula here. We cannot use this formula because n in the denominator here means that they're all equal. But all of our continents, all of our groups had different number of countries in each. But what we can do then, if they are unequal, if sample sizes are unequal, we use what is called the Tukey Kramer procedure. And it is just like the HSD. We can call it an HSD as well. And alpha. So we use the studentized range distribution Q from the Q table with C. So you find the right alpha for the page, and then C is the number of groups, and then N subtract C. So you look up those two degrees of freedom, multiply that by the mean square error from our ANOVA table, divide by 2, and then you can look at 2 of the countries at a time. And so that would be country 1, this would be country 2, or continent, I should say, not countries. We're looking at continents. So we would look at the number of countries within 2 continents at a time. Right. So let's take a look at Africa and Asia and see if they are statistically different, if there is a difference in the means. So the HSD for those 2 countries would be, we need to find Q of 0.05. C was 6 continents. This is 187, but remember how, so up here I'm going to do 0.05. Remember how the tables don't go to 187, so we're going to use the maximum on that table again, just like we did with the F ANOVA test. We will use 120. So we're going to use 120 here because it doesn't go up to 187. Then we're going to multiply that by the mean square error, which we calculated. You can check the ANOVA table, 35.82. Divide that by 2, and since we're looking at Africa and Asia, this will be 1 divided by 52 countries in Africa, plus 1 divided by 50 countries in Asia. And so we need to find that studentized range value. Let's go back to here. And we want not this table, we want this page. It's the same table, it's the same distribution, but we want the alpha equals 0.05. It'll give a different area or it'll give the area under the curve for 5% instead of 1%. So we look for 6 groups, right? The degrees of freedom for the number of so that's the number of populations in the numerator, the number of populations, so that's 6. And the degrees of freedom for the error was, well, it's 187, which would be somewhere between 120 and infinity, but we're going to use, let's just use 120. And if you can see that there, I'll just sort of bring that up. The Q value then we will use is 4.10. Okay, so you can compare it and see how different it is if we went to infinity. 4.03 versus 4.1. So 187 would be somewhere between those two. So we'll use 4.10. It's close enough. It will work fine. So it's going to be 4.10. We're going to multiply. So that ends up being 35.82 divided by 2 ends up being 17.91 times this expression. I'm going to carry many digits, 0.039230769. Keep all that into your square root, make sure it stays within the square root, and I get 3.44. That is called the critical difference. And what we do is we compare it to the actual difference. So the actual difference was 57.54. So that was the life expectancy for Africa. The life expectancy for Asia was 72.02. And we got 14.48. And we can see that the actual difference, 14.48, is greater than the critical difference, the HSD value. Therefore, we can say that there is a difference, a statistical significant difference in the life expectancy between Africa and Asia. Okay.